Of course, there is no weather in our sense of the word in space. Nevertheless, soil can also weather in the vacuum of space if it is constantly bombarded by high-energy particles, such as those emitted by the Sun. A research team from TU Wien has now been able to measure this in laboratory experiments. In just a few years, a Japanese space mission will take soil samples from Phobos and bring them back to Earth. Billions of years of particle irradiation. There are different theories of how the Mars-Moon Phobos could have formed, says Paul Szabo, who is working on his PhD thesis in the research group of Professor Friedrich Aumayr at the Institute. It is possible that Phobos was originally an asteroid that was then captured by Mars, but it could also have been created by a collision of Mars with another large object. When investigating such celestial bodies, one must always bear in mind that their surfaces have been completely changed over. The surface of the Earth remains unaffected by this, because our atmosphere shields the particles. However, the geology of celestial bodies without atmospheres, such as our Moon or Phobos, can only be understood if it is possible to correctly assess space weathering. Therefore, elaborate experiments were conducted at TU Wien. We used a mineral like it is found on Phobos and bombarded it in. The special properties of the Moon Phobos must be taken into account. Its distance from the surface of Mars is less than 6,000 kilometers, not even 2% of the distance between our Moon and the Earth. Just like our Moon, it is in a tidally locked rotation around its planet. The same side always faces Mars. The Martian atmosphere consists mainly of carbon dioxide, but in the outer regions of the atmosphere there are also larger amounts of oxygen. When particles from the solar wind penetrate there, oxygen ions can be created, which then hit Phobos at high speed and change the surface material. Data for 2024 space mission. With our measuring methods we were able to estimate the erosion of Phobos much more accurately than was previously possible, says Friedrich Aumayr. It is also important to distinguish between the two sides of Phobos. While the solar wind causes the weathering on the side facing away from Mars, the bombardment from the Martian atmosphere dominates on the other side, when the Sun is shielded from Mars. These considerations could soon play an important role in the evaluation of real Phobos samples. As early as 2024, a spacecraft is meant to reach Phobos as part of the Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.